now that we know what sequences are and we have seen some examples of sequences, I would like us to look at properties of sequences to study the way they can behave. And this first part will be about the boundedness of sequences. Let me start with the definition. What do I mean by a bounded sequence? So definition, it will have 3 parts. So a sequence AN is said to be bounded below if there exists a number, we'll call this number little b, it's a real number, such that the nth term of our sequence is greater than or equal to b for all indices n. Okay, this is when we say that a sequence is bounded below by this number little b, which we might call a lower bound for our sequence. Similarly, a sequence is bounded, can be bounded above if there is a number, let's call this one capital B, some real number, such that the nth term of the sequence is less than or equal to capital B for all indices. For all indices n. In this case, we say that the sequence is bounded above by this number capital B, which we might call an upper bound for our sequence. And finally, the last part of our definition is when a sequence AN is called bounded. This happens if there is a number C, a non-negative number C, such that the absolute value of the nth term of the sequence is less than or equal to C for all integers, for all indices n. Okay, let me just rewrite this in an equivalent way. This means that AN is between negative C and C. So you see why we had to have this number be non-negative. Okay, so the nth term of the sequence is between negative C and C, and this is when we say that it is a bounded sequence, and C might be called a bound for our sequence. So the way I like to visualize these notions is just to have our sequence AN be plotted in the following way. We use the horizontal axis to be labeled by our indices, so 1, 2, 3, 4, and so on, and we would use the vertical axis to measure the values of the terms of our sequence. So A1 might be up here, so that would be A1. A2 could be a bigger value, a larger one. A2 would be here. A3 could be, let's say, a negative, could have a negative value, and so on. You can imagine putting x's at the heights which correspond to the values of the terms of our sequence. So you can keep doing this, and this way we can understand that a sequence that is bounded below by some number behaves as follows. We would have at the height little b a floor so to speak, below which none of the terms in the sequence go. So all terms in the sequence are above this floor. This is when we have a sequence that is bounded below. Similarly, we can have sequences that are bounded above. Well, that would mean that there is some height, capital B, at which we have a ceiling to the sequence, and all terms in the sequence are below this ceiling. None of the terms in the sequence go above that certain ceiling, above that height. So this is when we have a bounded a sequence that is bounded above. And finally, we could, well, if these things happen, then of course we can also pick a certain height, a non-negative value for C, such that if we take this ceiling, take this line and reflect it over the horizontal axis, let's say here is negative C, then all terms in the sequence lie between these two lines, negative C to C. All terms in the sequence are in this strip of negative C to C. So this is how I like visualize these sequences. And to finish off the video, I would like you to consider these examples. So examples, I will give you a sequence an by a formula to be 2 to the n. So this is simply put the sequence of powers of 2. And what I would like you to do is to pause the video and vote below, decide which one of these properties does the sequence have. So is it a sequence that is bounded below? Is it bounded above by some number? Is it bounded, or maybe none of these things? That could also happen. So pause the video and vote for your answer now. Okay, I hope you voted and have found that this sequence is bounded below because all terms in the sequence are positive, meaning that they are all strictly greater than 0. So little b could be 0 for this sequence, and we would gain a lower bound for the sequence, which is bounded below. It is not bounded above, however, because each term in the sequence is double the previous one, so the numbers get larger and larger. There is no ceiling above which these numbers wouldn't go. And since it's not bounded above, there is no ceiling for the sequence, it cannot be bounded. Okay, for the next example, I would like you to consider the sequence an defined as negative n. So the nth term of the sequence is negative n. This is the sequence of negative integers, basically. Again, pause the video and decide which one of these properties does the sequence have. Okay, I hope you paused it. So this sequence is bounded above because the terms in the sequence are all negative, meaning they are all less than 0. So capital B for this sequence could be 0. It is not bounded below, however, because each term in the sequence is one less than the previous one, so there's no floor to this ceiling below which it wouldn't go. And it is not bounded, of course. So for the next example, I would like you to look at the sequence an equals negative 2 to the nth power. So it's a combination of the previous two in a way. What about this sequence? Pause the video and vote for your answer below. Okay, so I hope you paused it. This sequence is none of these things, so has none of these properties, because if you look at the terms in the sequence which have odd numbers for an index, for the first term you get negative 2, for the third term you get negative 8, and so on. For the fifth term you would get negative 32. So these numbers get smaller and smaller, while the terms with even indices, like the second term, are greater and greater, getting bigger and bigger. So the second term is 4, the fourth term is 16, and so on. The sixth term is 64, and you can see how they get bigger and bigger. So this sequence neither has a floor below which the terms wouldn't go, and nor a ceiling above which the terms wouldn't go. So finally, so this is not a sequence that is bounded below, nor above, nor it is bounded. Finally, I would like you to consider the sequence an being equal to 1 over n. Okay, what about this sequence? This is, if you look carefully, is just the sequence of reciprocals of natural numbers. Okay, pause the video and vote for your answer below. All right, so this sequence is all of these things. So it's bounded below by 0 because all terms in the sequence are positive, greater than 0. Next, it is bounded above by 1 because all terms in the sequence are less than or equal to 1. So capital B could be 1 for this sequence. We are dividing 1 by numbers that get bigger and bigger starting from 1, so they are all less than 1. And finally, since it's both bounded below and above, it is also bounded. For example, a strip of -1 to 1 would contain all terms in the sequence. Okay, I hope you got these right, and I'll see you in the next one.